Today we're going to talk about nth roots and rational exponents, and these are actually different forms of equivalent expressions. So we've done square roots, we've done cube roots. Now we're going to be looking at any root, which is why we call it nth. So it could be a 7th root, a 21st root, so on and so forth. So we have two main learning goals for today. We need to be able to simplify expressions that have rational exponents as well as nth roots, and we need to be able to use nth roots in order to solve equations. So when we say nth root, the number root of a is expressed like this. So when we have a square root, we just wrote the symbol just like this, because if no number is written, it's understood to be a 2. However, when we moved to cube roots, we wrote the little 3 kind of in the little crease there. And that's what we do for all roots other than square roots. So whatever the number is in here, that's the root that you're needing to take. We call that number the index of the radical. And that'll be important because I'll refer to that frequently. We'll say, okay, what's the index of this radical? We can express nth roots not only as radicals with their number here in the little crease, but we can also write them in an additional form with rational exponents. And remember, rational means can be written as a fraction. So rational exponents, just fancy saying fractional exponents. So we're going to have exponents that are fractions now. The index, when you are writing a nth root in fractional exponent form, the index is going to be the denominator of the fraction. And the exponent of the radical is going to be the numerator. So let's say that I had the 7th root of x to the 5th power. This, because the denominator of the fraction would be the index, that means the denominator, so x is my base, the denominator is going to be my index, so it's going to be 7. And the exponent of the radical, so 5, is going to be the numerator. So these are equivalent forms. 7th root of x to the 5th is the same thing as x raised to the 5/7 power. So we should probably know how to do both of these forms on your calculator. So if you want to enter a fractional exponent, you're going to use this caret button. Now, this note here is only on the older models. If you have one of the newer models where it automatically makes the actual fraction bar in the exponent, then you don't need to worry about the parentheses. But if you have an older model where you literally see the caret after you press it in, then you need to make sure you enclose that fraction in parentheses, otherwise you will not get the correct answers. So that's how we enter fractional exponents. If we want to enter an nth root, we did this earlier in the year, but I'm sure many of you don't remember. You have to key in the number of the index first. So if you want to enter in a 7th root, you have to press 7 first, and then you hit the math key. Then you're going to choose choice 5, because choice 5, I think it looks like this, like x root. So you're going to choose that one, and then you just key in whatever number you want to take the root of and press enter. Now remember, your calculator is not going to calculate roots of something that's a variable. So this you can only press things in if they have number bases instead of variables here. Now, something to keep in mind now that we're taking all kinds of roots and not just square and cube roots. If your index is odd, then there's only going to be one answer. So one answer if the index is odd. And that answer is just going to be whatever the nth root is. So if we have the cube root of 8, there's just one answer. The cube root of 8 is 2. If the index is even, however, and a is positive, this is something we learned with square roots, but it now applies to all even positives. All even positives, there are two answers because you have to remember the plus and the minus. So you're still going to take that nth root just like you would if it were an even index or an odd index, but because it's even, so square roots, fourth root, sixth root, eighth root, any root that where the index is even, you have to remember the plus or minus. So plus or minus. If the index is even and a is 0, then there's just going to be one answer because the square root, cube root, fourth root, any root of 0 is just 0. Then finally, if you have an even index and a is negative, then that means there are no real nth roots. There will be two imaginary roots in that case. So again, don't forget the plus or minus, but there are no real roots if the number underneath is negative. All right, so let's look at our first learning goal and being able to simplify expressions that have rational exponents and nth roots. So here we're just going to rewrite. So rewrite the expression using rational exponent notation. So, and it should be clearer on your paper than it is here on the screen, but that says fourth root of 14. So all we're doing is exactly what I did up here. We're saying, okay, 14 is my base. I know it's a fractional exponent. Whatever the index is my denominator, so that's a 4. Whatever the exponent is, well, there isn't one. So if there is no exponent, that means the exponent is understood to be 1. So we rewrite that 14 to the 1/4 power. So I'd like you now to do B real quick. Shouldn't take you more than 10 seconds. Do it yourself here. Pause for a second and then come back to see if you got it right. So my base is 2 here. Got my fraction. The denominator should be 8. The numerator should be 11. So 2 to the 11/8 power is what you should have here. Example 2 is just going the opposite direction, working backward. So here, my base is 6, so I know that's going to go under here. And my index should be 3. Since this is a 1, that means it's to the first power, which means I don't actually need to write it. So cube root of 6 is equivalent to 6 to the 1/3 power. All right, so again, pause it here. You try B, see if you've got it right. So you should have fourth root of 8 to the 7th. Also, you can also write these with, and sometimes this is actually helpful to do it this way, but you can write the exponent on the outside as well. Either of those are correct and they're equivalent expressions. All right, example 3, find the indicated nth root of a. So if n is 5 and a is negative 32, so that means I want the fifth root of negative 32. This is an odd index, so there should just be one answer. So fifth root of negative 32, if you punch that into your calculator, if you don't know it already, is negative 2. There's just one answer, and that's it. On B, if n is 4, that means it's asking for the fourth root of 625. So go ahead, pause it for a second, come up with your answer, and then come back to check. All right, fourth root of 625, if you just punched it in your calculator, is 5. But remember, even index, you need the plus or minus. So plus or minus 5 should be your answer there. Okay, example 4, evaluate the expression without a calculator, meaning that you need to show your work if you want credit for these on both the practice problems and quizzes or tests, because this is not trying to see how you can press it into your calculator. This is trying to see how you can apply and simplify using the rules. So here, I'm going to convert this back into nth root notation. So if the denominator is 2, that means it's just a square root. So square root of 49. And my exponent's 3. Since I know that the square root of 49 comes out evenly, I'm going to put my exponent on the outside and work on it that way. Square root of 49, hopefully we all know, is 7. And so then 7 to the third power. Now, again, it does say without a calculator. If you don't know what 7 to the third power is, you can certainly press that in because you've shown the work here, showing that you know how to do the problem. So the answer should be 343. All right, let's try B here. 16 to the negative 3/4 power. So denominator is 4, so that means that's my index. So 4th root of 16. And then my exponent is negative 3. Now, we should know what to do with negative exponents, so that shouldn't make us panic. 4th root of 16, if you didn't know, is 2. So now we've got 2 to the negative third power. Again, if you use your calculator and don't use exponent rules, you're going to get a decimal. We need a fraction, and you need to show the work. I don't just want the answer magically after this. Negative exponents, remember, the rule is to reciprocal them. So that goes to the bottom. I put a 1 in my numerator as a placeholder. And now I simplify. 2 to the third power is 8. So my final answer here is 1/8. All right, I would like for you to try C on your own to see if you can come up with and apply the rules with the appropriate work. So pause it for a second, work it out, and come back to check. All right, so here's your test if you did it right or not. 5th root of negative 32, and then my exponent is negative 2. So I'm going to work inside the parentheses first. The 5th root of negative 32 is negative 2. And since I'm taking that to the negative second power, that means I need to reciprocal it. So my negative 2 goes to the bottom and becomes raised to the positive second, 1 in the numerator for a placeholder. Negative 2 to the second power is positive 4. So your answer should be 1/4. So hopefully you got that correct. Again, remember that negative numbers are different than negative exponents. This is what made us do the reciprocal, not the negative inside. This negative exponent made us do the reciprocal. All right, last part of this lesson, and it goes with our second learning goal, being able to use nth roots to solve equations. So these should be super easy. The key is that you have to get the exponent term alone first. So get the exponent term or the power alone first. Most of these they are, but if they're not, you need to do that. So here this is already alone. So all we're doing is we're saying if I want to undo a 5th power, I need to take the 5th root. So I'm going to take the 5th root on both sides. Notice the directions say to round to the nearest hundredth when appropriate, so meaning if it doesn't come out evenly, you can go ahead and round these. So 5th root of x to the 5th, these cancel each other. That's the whole point, just like square roots undo squareds, cube roots undo cubes. So I've got x, and then 5th root of 10 here is 1.58. So that is my answer, approximately. Now, second one, my power is not alone. I need to first divide by 6 before I do anything else. So that gives me x to the 4th equals 625. Now, remember, anytime you are solving and you have an even exponent, remember that that's going to need a plus or minus in the answer. So to get this x to the 4th gone, I need to take the 4th root on both sides. So x equals, again, because it's an even index, I need the plus or minus. Fourth root of 625 is 5. So positive and negative 5 would both be solutions. And again, you can see the difference. If you plug in this for x here, 1.58-ish is the only thing you can plug in. But here, you could plug in negative 5 for x or positive 5 and still get it to work. All right, this one looks a little bit different, but the power term itself is just in parentheses. So the power term is alone, it's just that this whole expression is the base. So to undo that fifth power, I'm going to take the fifth root on both sides. Again, the fifth power and the fifth root undo each other. This is an odd index, so I don't need to worry about plus or minus. I've just got y minus 1 equals, fifth root of 32 is 2. And so then to solve for y, I need to add 1 to both sides, and y equals 3. All right, last one, x plus 1 to the third equals 18. Again, I've got my power term alone, so I just need to take the cube root here on both sides. Again, we love odd indexes because odd indexes mean we don't need to worry about the plus or minus. So I've just got x plus 1 over here. Cube root of 18 doesn't come out evenly, so we're going to approximate it here. So I'll give it the squiggly equals. It's about 2.62. So then subtract the 1 on both sides, and x is approximately 1.62. All right. Hopefully you feel pretty comfortable with fractional exponents and nth roots. That is it for today's lesson.